Now this question says we have been given a long cylinder. So this is the long cylinder that is given to you. Now refractive index of this glass rod. So this is made up of glass and the refractive index of this is 3 by 2. That is also given. And it is immersed in a liquid of refractive index 3 root 3 by 4. So the outside you have a refractive index is 3 root 3 by 4. This is the perpendicular and the ends of the rod are perpendicular to the central axis of the rod. So this is perpendicular. So this angle is 90 degree. Now find out the maximum angle theta so that internal reflection takes place. Total internal reflection. So we have to find condition so that after this ray, let us say this ray meets here and then this goes here. So total internal reflection. So let me make the diagram again. So you have something like this. So this is the cross-sectional view you can see. And this side you have, so let us make slightly big. And now this is the axis. So you have this axis. So this is the axis of rod. Now let us say a light falls here and that makes an angle theta with the normal. And now this is 3 root 3 by 4. So this is 3 by 2, that is 1.5. And this refractive index is 3 root 3 by 4. So 3 root 3 by 4 is less than 1.75. You can check what is the value of 3 root 3 by 4. So 3 into root 3. So let us say square root of 3. So this is 3 root 3. And this divided by 4. So this divided by 4. Answer divided by 4. So this value is 1.299. So this is around 1.299. So 1.299. So this is less than. So this side you have rarer medium and this side you have denser medium. So this is rarer and this is denser. Now let us say what will happen if a light goes from rarer to denser. It bends towards the normal. Are you getting or not? So this means this light ray has to go in this direction, but it will not go in this direction. It will bend towards normal. So let us say this bends towards normal somewhere here. And let us call this angle as R. Now if this angle R, now I want to take total internal reflection at this surface. So what will happen? Let us say this angle is 90. So I know this angle. This is I is equals to 90 minus R. Now if total internal reflection takes place at this surface, I have to satisfy the condition of total internal reflection at this surface. Are you getting? So let us say if total internal reflection takes place at this surface and the light rays come in this direction. Are you getting? So light rays is coming in this direction. Now we can write these equations and then we can solve. So let us say write surface at this surface. What is the equation? So if I write this surface, n1 is 3 root 3 by 4. So 3 root 3 by 4 into sine theta, because the angle of incidence is sine theta, is equals to n2, that is 3 by 2 sine r. Sine r is this angle. So this is sine r. So this is 1. Now if I write the same thing at this surface, now n1 sine theta, n1 is 3 by 2, n1 is 3 by 2, and sine theta is how much? This angle of incidence is r, and r is nothing but this angle, let us say call I, and I is nothing but 90 minus r. So I can write I is nothing but this is equals to 90 minus r. So I can write sine I, and sine I is nothing but 90 minus r. This is equals to n2. n2 is 3 root 3 by 4. And total internal reflection takes place. So condition of total internal reflection, this angle has to be 90 degree. So n2 sine 90. So this is the condition 2. And now we have to solve these two conditions. Are you getting? And then we can solve for theta. Now from equation 2 I can write. So let us say from 2 I can write 3 by 2 sine 90 minus theta, that is cos r, is equals to 3 root 3 by 4 Sin 90 is 1. So this value is cos r, I can calculate. 3 goes, 2 also goes. So we have cos r is equals to root 3 by 2. Are you getting? Now if I know cos r root 3 by 2, that is that theta is equals to how much? R is 30 degree. Then only have root 3 by 2. Now plug the value of r in equation 1. So from 1 I will have 3 root 3 by 4 into sine theta is equals to 3 by 2. Sine 30 is 1 by 2. Now 1 by 2 and 1 by 4, so this is root 3 sine theta is equals to 1. So we will have basically sine theta is equals to 1 by root 3. So this is the maximum required angle. Are you getting or not? So this is the maximum angle. Find out the maximum value of theta. This means any ray that is coming here, that will have total internal reflection, because in these cases r is smaller. So you can verify yourself, all the ray that is coming middle this will go total internal reflection. Are you getting? And after this ray you will not have total internal reflection. For this ray there is no total internal reflection. For these rays you will have total internal reflection, that is TIR is possible for these rays. Are you getting? And not for this ray, this total internal reflection is not possible. So theta is basically sine inverse 1 by root 3. So if the theta is maximum, theta is this, you can have a total internal. Now another important point, if this has reflected, totally internal reflection takes place at this surface, angle of incidence is equals to angle of reflection I. Now if this is the case, so total internal reflection at this surface will also take place. So if you extend this line here, now you see, if this is the angle I, then this angle is again I. Are you getting or not? So this angle is I, this angle has to be I. This means at this surface also total internal reflection will take place. This means light will go in this direction. So this is the idea of optical fiber. What you have, so whatever the energy you send between these two, whatever the ray you send between these two, all ray goes through this pipe or this glass cylinder in this case. So this means if we have a optical fiber, so let us say this is your optical fiber. Now if you send a light from here, this goes here, and this gets totally internally reflected here, and this goes totally internally reflected at this surface. So it keeps going on. So you have a total internal reflection. In this case, if you send some another light, also that also go total internal reflection. Are you getting or not? So this reflects here, and then this goes here. So you will have a case of total internal reflection. All light goes totally internally reflected. Are you getting? So this is the idea behind the optical fiber. So optical fiber works on the principle of total internal reflection. Are you getting? So maximum theta, you can derive a result between mu1, that is the material of optical fiber, and mu2, that is the material outside. So you can find theta max as a function of mu1 and mu2. This is the task. So for you can do the same thing. What is this meaning? So you have optical fiber. So this is the optical fiber is given, and this is the principal axis of optical fiber. A light is incident at angle theta, and now this light ray goes total internal reflection. This has to go something like this. This goes total internal reflection. What is the condition for theta? And in terms of mu1 and mu2, mu1 is this and mu2 is this. So you can verify what is theta is equals to theta max. So find out the value of theta max. So do yourself. So do yourself, and you will find a good result is coming.